I'll perform basic programming operations for PLCs. In this process, I will start with the installation and configuration of the software, gradually explaining how to create projects, write programs, debug code, and apply the programmed logic to real-world industrial control scenarios.
Today, I will demonstrate the basic programming for the PLC using the Courtesy software. First of all, we have to start with the ladder diagram. Let's begin to create our project here. And add object LD. We will create an example of the ladder diagram. LD example 1. We should choose the type of PU program and choose programming language LD. The ladder diagram looks like this. We'll have the declaration of the variables on the top, and we can't write the program here yet. The program will consist of 6 inputs, using sample logic and/or conditions. Starting with adding switches and lighting together. A, B, C, and output in a coil like this. This is LD, and we can divide the ladder as needed. For the declaration of variables, we'll use various data types, such as arrays or booleans. Now we'll use the boolean type and click OK. This is automatic declaration, and we will configure everything here. For example, the lamp can be turned on or off, like lamp 1. We will add a more complex logic to this. The logic here is parallel. We will use different variables, for example, LDF and doubles. LDD and LDE. I will remove the variable declarations for now. I want to declare them as global variables. Global variables are accessible by all functions and programs. This means that every function in the program can access and use these global variables. Now, let's execute the main program. Here's the main program, and I will add more outputs. For example, in this case, we will call it example 1. If logic A, B, and C are all on at the same time, the output will also be on. Logic A can be substituted with logic F, and similarly for logic C, we can use logic E or D. If we visualize the program here, I have already set up the variables. If we flip through the program, everything should be set, and the output will show 0 error warnings. Now, I will log in and run the program. If A, B, and C are true, the light should turn on. If something goes wrong, the output may not turn on. I will check the name of the output. Perhaps there's a mistake in the output name. After fixing it, we can rebuild the program. If we run the program, the light should turn on and off properly. We should test the logic now. Next, we will add a timer function, specifically a time on delay. This function allows us to set a delay before the output is triggered. In this example, we will set it to 10 seconds. When the condition is met, the timer will delay for 10 seconds before the output turns on. For the time on delay, we can see the program with an instruction list and function block diagram. We will add more networks, including more complex logic, and the output may be lamp 1. Lamp 2. Or something else. We will set up the timer as well. Timers allow us to define the duration, and we will set it accordingly. Now we can visualize the program. The light should turn on after 10 seconds. If the logic conditions are met, the program will run and wait for the delay before the light turns on. The final step is to copy the variables into the global variables section. This will allow them to be used across the entire program. Okay, pass the variables to the global section. Now, let's go back to the visualization. I have set up the lights and timers correctly. When we run the program, the lights will follow the logic as expected. The timer will delay for 10 seconds, and the light should turn on. We will test this by triggering the conditions and observing the delay. After 10 seconds, the light will turn on, and the cycle will repeat. If you're unsure how to use any of the program's functions, you can search for more details in the help section.